much easier separation. I've put in here guidelines how to make a sand bed. Typical sand drying bed. Sludge is placed on the bed in a 200 to 300 milliliter layer and allowed to dry. Then sludge dewashes by drainage through the sludge mass and the supporting sand layer by evaporation from the surface to the air. Most of the water leaves the sludge by drainage. Thus, the provision of adequate drainage is very essential, especially if you want to recycle and use it again in the wastewater. Drying beds are equipped with natural drainage lines, perforated plastic pipes, or vitrified clay pipes laid with open joints so that you can allow the water to go into the pipes. Sloped at a minimum of 1%. The drainage pipe should be adequately supported and covered with coarse gravel, so the fine material is not clogging the pipes. Sand layer should be approximately 300 millimeter deep, with allowance for some loss from freezing operations. When you remove the ash, then you would probably take some of the sand with you. Then you would have to fill more sand back. Sand should have a uniformity coefficient less than 4 and a size between 0.3 and 0.75 millimeters. Pretty fine particles. It will give a good separation. Here's how it could look like. Inflow up at the center here and then drain off pipe at a lower level. And then again below you feed this water back to a tank where it's recycled. Here, coming in here, could come in at the end and then let the water flow out and drain it back to recycling again. The lowest part of the slope, the beginning of the slope. So much about the environment. If we look at the dialed energy, then we see we have very low carbon monoxide, we have low emission of particulate matter, we have low NOx, we have very good control of the combustion. And that gives high efficiency, and at the same time we reduce the environmental impact. So something which is, I've met people when I have started on a project with energy efficiency, then I said, we have to do like this, like this, like this. And then they said, no, we're going to jeopardize our process, our production. I did it on a brick factory in Denmark where they were drying clay. And after the drying, they were burning the clay. Then we were recycling heat from the burning process to heat up air for drying of the clay. Previously, before we started the project, they had a pretty high waste during the drying process. If you dry the bricks in the drying chamber, drying kilns too fast, they crack, because it gets hot, and then the moisture inside the clay wants to come out, and then it cracks. So there was a huge waste, but by optimizing the system from an energy efficiency point of view, we also had to have an energy efficient flow through the drying kiln, and we ended up with reducing energy consumption, reducing the waste of the drying process. Then I made a similar, almost similar setup in Lithuania at a furniture factory where they were drying timber for the furniture factory. They had some old Russian drying kilns operating with steam, and they had about 10 to 12% of the timber going in the drying kilns was cracked and could not be used. Then I said, we have to use hot water, and they told me, you cannot use hot water for drying the timber. So of course you can know. So okay, what is the timber inside the kiln? It's about 70, 80, 85 centigrade. And you need steel to make 85 centigrade temperature. Yes? I said, in Denmark we do 90 centigrade with hot water. And then we called for proposals from Austria for a drying kiln for the sawmill. We installed 2 new drying kilns. We minimized the loss on cracked timber from 12% to 2.5%, 3%. At the same time, we reduced energy consumption. So we really improved the process and improved energy use. So don't be afraid if you have a process. I was working in Thailand with a glass manufacturing company. They were sending out flue gas at 500 centigrade from the kiln where they are melting the glass. And then I suggested we should make recovery of this, and they completely denied it. They were afraid we would damage the production. So they're still running, wasting a lot of money on gas going out at 500 centigrade. They could put up heat recovery and put up an absorption chiller, and then they could make district cooling for the whole industrial estate with all that energy. Any comments, any questions on the environmental side of biomass and coal-fired systems? We need a microphone. Okay, yes. Yes. It depends very much on how your bagasse looks like. If your bagasse is after milling of the cane, then I have seen bagasse coming out as pretty long fibers. But I talked to somebody earlier here today, and they told me the bagasse they have is more like small particles, more like chipped wood we saw. So how is your bagasse? Okay, but if you have fine bagasse, you could easily mix it with rice husk without any problems, burn it together. Okay. Yes. Yes. Yeah, yes. Yes. I would recommend if you could find a way to dry the bagasse before mixing it, because you have the rice husk is with very low very high aspect but very low moisture, and you have the bagasse with very high moisture, slightly bigger particles. That's not easy to combine this, but if you could dry the bagasse before feeding it to the boiler, then I don't see any problem. The problem with the rice husk is it's not, the density is very low, it's very bulky, and if you increase the air, as you say, then you suspend the rice husk, it starts flying across the boiler. Yes, and even if it's burst, then you will have high velocity with silica. That's the way you make sandblast. Yes, for sure, and also the boil. But if you, one way, when I was a kid, I'm from the countryside, I had some of my classmates, they were farmers, And after harvesting, we were drying the grain, the wheat and the barley, because we could get a higher price if it was dried and we sent it to the mill. So we were trying to dry it, and we put up supply of air. It was wooden boxes actually, turned upside down, so the air was coming from the bottom. And then we put the grain, the wheat and the barley on top of it, and then we were blowing hot air through these wooden pipelines, and then we could dry the grain. Then the hot air was passing out through the grain, and we could minimize the moisture. This could be a simple and cheap way to dry your bagasse.
If we add some moisture to the license, up to some extent.
Yeah, but it's difficult because rice husk is not hygroscopic. In Thailand, they store rice husk outdoor because it's not soaking water. It gets wet, okay, and some water will stick on it, but it's not soaking it into the biomass. There's like a fine bags or varnish on the rice husk, so it's not soaking up the water. It would be very difficult to do it, to keep the density of the rice husk, make it higher. Yes. Yes. You can. Yes. Sure. Yes. No, but if you can get it instead of 50%, if you could get it down to 20%, then I think it would be possible to reach it without big problems. Municipal solid waste. Municipal solid waste is also like 50% moisture. And again, it's very difficult to burn water. I have a small video of a different way of handling municipal solid waste. Let's do it. It's 4 minutes. Okay, I'll show it to you. You see a lot of plastic bags with garbage inside plastic bags. Then it's handled by equipment like this, a front loader. They're handling 150 ton municipal solid waste per day, and there are 3.5 people doing it. The manager has got other jobs, so he's there only part-time. So there's 3.5 persons handling 150 ton municipal solid waste per day. Here they're putting the collected waste into a bag opener. It's a plug, a shredder. Their knives running very slowly and whipping the bags open. And then after this, it's passed through a screen. It's a rotating screen where the bigger pieces of plastic are coming out, and then smaller pieces, organic matter, but also other impurities are coming out below the screen.